This is a great quote that was in your book. Science is built of facts in the way a house is built of bricks. But an accumulation of facts is no more science than a pile of bricks is a house. Just a bunch of random facts does not make science. In science, we take the facts and we organize them and we categorize them. There are millions of chemical reactions. And just having a long disorganized list of them would not really help anybody. And so what we do is we classify reactions into categories. And we do this in our everyday lives as well. We group things, right? It's like, okay, well, these are socks. I'm going to put all my socks in the same drawer. And some people, really get off on grouping things, and they're going to put all the black socks on one side and the white socks on the other, and then they'll, have this rainbow in between or something, right? So you can go a little crazy in classifying, but grouping things helps. Because if one of your socks is in the silverware drawer and the other is on the back of the toilet, when you go to get dressed, you're going to have a hard time finding your socks, right? Because we don't know where they are. They're all jumbled up together. So we naturally categorize and organize things, and that's what we do with chemical reactions. So we're going to learn one method of categorizing, and it's these 5 reaction types. And they're combination, decomposition, single replacement, double replacement, and neutralization. And these names are descriptive of what's going on in these reactions. So in a combination reaction, this is a general equation here. There is no element A and there's no element Z. So these are just standing in like variables. You take 2 different substances and you combine them into one. We can identify a combination reaction because it has at least 2 reactants but only 1 product. A decomposition reaction is kind of the opposite. We're starting with one substance and it's decomposing, it's breaking apart into 2 or more substances. And this little triangle, what does that mean? Heat. Oftentimes, heat is necessary to decompose, and so we'll show that above the arrow. In a single replacement reaction, we have one element being replaced by another. Here's a compound. There's B and Z, and here's A all by himself. And A comes in and replaces B in the compound, and then B is left by himself. This is like a guy going alone to a party, and here's a guy and a girl at the party. And in the course of the chemical reaction, the girl decides that she likes guy A better than guy B, and guy B has to go home alone. So a single replacement. In a double replacement, I guess from the standpoint of the people involved, this is maybe better, because here you have 2 couples going to this party, and they end up switching partners. At least nobody's left out now, right? They mutually decided, no, I like this one better. Well, hey, that's okay, because I like her better, and they swap. 2 replacements, double replacement, okay? A neutralization reaction involves an acid and a base, and we've learned how to recognize acids. So here we're showing an acid as HX, where X is some anion. So here we've got the acid, and bases are usually going to be metal hydroxides. So we'll see a hydroxide here. And then we're going to end up with a compound between the metal from the metal hydroxide and the anion from the acid. So this is an ionic compound. And then we've got this guy. And that looks kind of funny, doesn't it? What would be a better way to write that? H2O. But what we're trying to show you here, this is a type of double replacement. You see that? Here H came in with X, and H left with OH. B came in with OH, but now B leaves with X. So this is also a double replacement. They are swapping partners. Any questions? So we're going to talk about each of them individually as well. But here are some examples. We should be able to look at a chemical equation and identify what type it is. So let's look at this first one. So here we have zinc. Is this an element or a compound? That's an element. So this guy's coming in by himself. And here we've got copper and sulfate. Is this an element or a compound? That's a compound. This is, in fact, is an ionic compound, isn't it? We've got copper ions and sulfate ions. And then what happens at the end? We've got zinc with the sulfate and copper by itself. Single replacement. Zinc took copper's girl. A single replacement. You like that? Okay, so we'll call that SR, single replacement. The second one, 2SR plus O2 gives 2SRO. Combination. We only have one product. We have two things combining into one. So that's combination. I'll write that C. How about this next one? CdHCO3, that's cadmium hydrogen carbonate, forming cadmium carbonate plus water plus carbon dioxide. Decomposition. We recognize a decomposition reaction because there's one reactant and it decomposes, it falls apart. So we'll abbreviate that. D for decomposition. How about this one? It is a double replacement, but it's a special double replacement. What kind of a compound is this? It's an acid. And this is a base. Bases have OH in them. And we're ending up with a compound and water. So the big clues for you at this point in your chemistry career, we've got water there and we've got acid. Acid is one of the reactants, water is one of the products. This is a neutralization reaction. It is also a double replacement reaction. What about this last one? That's double replacement. Neither of these is an acid, and neither of these is water. Here, silver came in with nitrate, and he leaves with chloride. Potassium came in with chloride, but potassium leaves with nitrate. They both swapped partners. Two swaps, two replacements, double replacement. Any questions? That's not too bad, is it?